Okay, so let's do this question. Three gases X, Y, and Z were mixed in a closed container and allowed to reach equilibrium. A change was imposed at time t and the equilibrium was re-established. The concentration of each gas is plotted against time. Alright, so we have a system. We have three gases, X, Y, and Z. It's a closed container, and it was allowed to reach equilibrium. A change was imposed at time t. So this is time t, and the equilibrium was re-established. The concentration of each gas is plotted against time. Okay, so the equilibrium was allowed to re-establish. Always in these types of questions, we ask what happened at time t. And we can see that the concentration of all three chemicals, all three gases, the concentration of all of them dropped. Now, the obvious explanation for this is the volume of the system was increased. So the volume went up, because when the volume of a system goes up, all of the chemicals, all of the gases inside of it naturally will have less concentration, because concentration equals moles per volume, moles divided by volume. The concentration of a gas equals moles divided by volume. So if you increase the volume, you're increasing the denominator. The moles is unchanging. You're not adding or removing any gas from the system, from the container, because it's closed. So the concentration of everything will go down because you're dividing by a higher volume. And we saw that after the volume was increased, the concentration of X, so after T the system tries to re-establish equilibrium. So these are the what I've just labeled. These are the concentrations after the change at time t, and then after a bit more time, you see some change happen in the concentrations. This is the system trying to re-establish equilibrium. So let's see what changes happened. The concentration of X went down. The concentration of Y and Z both went up in equal amounts. So which reaction does the graph represent? X plus Y goes to 2Z. That doesn't really make sense because the concentration of X went down. So remember, the equilibrium being re-established after time t change means the reaction the reaction is either moving to the right or moving to the left. Overall, that's what reestablishing equilibrium means. So this is equilibrium, and then this is where the system is at time t after the change. So it will try moving towards equilibrium or from the other direction. So if it was x plus y goes to 2z, then that doesn't make sense because x went down and y went up. And z went up as well. So how would that work? If it's going in reverse, then you'd expect both x and y to go up. If it's going forward, you would expect both x and y to go down. However, x and y are doing contradictory things. So it's probably not A. Let's check the other answers. 2x goes to y plus z. 2x goes to y plus z. So y and z both had concentrations increase in equal amounts. So the change is proportional to the mole ratio. The change will be proportional to mole ratio. Now we can see that the change in x and the change in y and z, it's a 1-to-1 change. This amount and this amount, these are the same amount, so it's 1-to-1. But the change in x as well is the same amount as these. The size, the magnitude is the same. So it can't be 2x goes to y plus z because the decrease in x, the magnitude of the decrease in x, is actually the same amount as the magnitude of the increase in y. And it's also the same magnitude as the increase in z. So these are all in 1-to-1 mole ratios. 1 mole of x decomposed to form 1 mole of y and 1 mole of z. That's what's happening in the system. So it can't be B, can't be A, can't be B. 2x forms y plus 3z. Again, you need to preserve the mole ratios of the concentration changes will preserve the mole ratios. These are all 1-to-1 changes. Let me just illustrate what it would look like if it was this one. So you'd have the changes occur. Actually, I'll draw over here. So if it was this reaction, then the change would look more like 2 moles of x forms 1 mole of y and 1 mole of z. It would look like this. So the change would be 2 to 1. Let me just mentally check that. 2 moles. So 2 particles of X would form 1 particle of Y and 1 particle of Z. That's possible. It's counterintuitive, but it's possible. So the answer is D, because these are happening in 1-to-1 ratios. The only thing I'm wondering is, would it be that? Or would it be this? If the reaction was that, would it be half to 1-to-1? No, because if you took 0.5 moles of X and you formed 1 mole of Y and 1 mole of Z, then that is not equal to this. Does not equal this reaction. Okay, yeah. That makes sense. So if the system is exactly 1 liter, we can just treat these as moles. So 0.1 mole of X. Anyway, so 0.6, 0.7, 0.75. This is 0.45 over here, over there. And this is 0.3 right there. And then it becomes 0.35. Y becomes 0.5. X becomes 0.7. So yeah, 0.05 moles. 0.05 moles of X formed. We lost 0.05 moles of X and we formed 0.05 moles of Y and 0.05 moles of Z. So yeah, it is 1-to-1. Sorry, that's not even what I was trying to answer. I was trying to answer, it would be this one, because you'd get, anyway, the answer is D. Yeah, the answer is D. Practice run 1.